discuss buffer solution. Children, what is the buffer solution? We always heard this word, buffer solution. But what is buffer solution? Buffer solution actually is defined as a substance. Buffer solution is defined as a solution which resists drastic change in the pH when a small amount of acid or base, even if it is strong, or even water added, but still the pH value of the solution will not change. Let us see what is that. If suppose I am taking any solution having particular pH value, we all know what is the pH value. We all know what is pH value. If suppose I am adding, suppose the pH value is 0.5, or I am taking just 5, pH value is 5. Now the solution is what? Tell me. It is acidic, basic or neutral? It is acidic. You know, if pH value is 7, it is neutral. If it is less than 7, any value, then it is acidic. And more than 7 up to 14, it is what? Basic. I have taken a solution having pH value what? 5. If I am adding HCl, concentrated HCl, a strong acid, now what will happen? Solution will definitely become more acidic. Means the value will change from 5, it may go to the 4, depending on the amount, how much acid I am adding to this solution. Now, here comes the buffer solution. If I am taking another solution, it is also a solution, but if I am adding HCl to it, its pH value will not change. If the value is 5, it will remain 5 even if you are adding such a strong acid. Of course, you have to add in a small amount. And the pH will not change even if you are adding a strong base like sodium hydroxide. pH will also not change by adding a little bit amount of the water. So this kind of the solution is known as the buffer solution. Known as what? Buffer solution, which resists the change in its pH value. How it happens? How it is possible that we are adding acid but the pH value is not changing? Don't worry, it's not a miracle, it's a simple chemistry. Here some chemicals are present which will consume hydrogen, hence the pH value will not be allowed to increase. Similarly, the chemical substances will consume the new hydroxide ions and hence the pH value will not be allowed to change. We will be seeing this mechanism in great detail, but before that, let us see how this buffer solution is supporting, is useful in our day-to-day life. And this may come as a very important question to you, the applications of the buffer solution. So first let's revise the definition. Buffer solution is defined as a solution. Buffer solution is defined as a solution which resists. Resist means it doesn't allow, or even if it is changing, it will change only to a very small extent. So it resists a change in its pH value even if you are adding a strong acid or a strong base or small amount of water. And of course, the acid and base, whatever you are adding, that should be added in a small amount. So this becomes the definition of the buffer solution. You please learn the definition, write it and practice. Keep the main points in the mind. The pH value will not change, will resist to change. Even if you are adding strong acid, small amount of the strong acid or strong base or even the water. Now children, let's see what is the application of the buffer solution. Application of the buffer solution is, first of all, we are ourselves. Our blood is having a definite pH value 7.36 to 7.42. If suppose pH value changes from this level, life will not survive. Death is sure. Because of this pH value, several activities, several biological processes are going on in our body. But this pH value 7.36 to 7.42, this is the range of the blood pH. How body maintains, which chemicals are there which are acting to maintain that pH value? It is bicarbonate and carbonic acid. These are the two chemicals which maintains the pH level of the blood. You take anyone's blood, it is slightly alkaline because it is more than 7, no? Slightly alkaline. 7 is neutral, little bit more, so alkaline. So blood is slightly alkaline in the nature, slightly. Bicarbonate ion and carbonic acid which are present in our blood, they maintain this pH value. Hence, if any injection is to be given in the veins, they have to maintain the pH value, this. Now, we will be seeing another application, that is agriculture. Very important process. Agriculture. Soil. All the soils we are not same. They have got different values of pH. And depending on that value of pH, the use of fertilizer, whatever we are using, that depends on the pH value of the soil. How the soil maintains that pH? Because of the chemicals. Which chemicals? Carbonates may be there. Bicarbonate, sodium bicarbonate and phosphates. These chemical substances which are present in the soil, they maintain a pH level of that soil. Thereafter, industries. Paper industry, dyes, colors, ink, paint, drugs, even the foods, that packets of the food, whatever we are consuming, they also are kept in that particular pH level. Cold drinks, whatever you are drinking, because of the chemicals, you can use it even after months of manufacturing. Medicine, penicillin, very important medicine. How it is manufactured? While preparing it, we need a particular buffer solution. And that is obtained by using sodium citrate as a buffer. Sodium citrate is used as a buffer. Another buffer solution is citric acid we add to the milk of magnesia. It's an important question, generally comes in the exam. What is milk of magnesia? Magnesium hydroxide. When we combine these two, which two? Citric acid and milk of magnesia, it becomes a buffer solution. Thereafter, analytical chemistry. Analytical chemistry means what? Analyzing, you are finding out something. You are doing the analysis. In the analytical chemistry, whenever you go in your lab, of course now due to corona you are not going, But whenever you will go into the lab, you have to do the detection. You have to find out a given unknown substance will be given to you, and you have to do the chemical test to find out. These substances have been classified in several groups. So group 3A, all the chemical substances which are classified, all that substances which are present in the group 3A, while finding out them, while detecting them, we need a particular pH level of 8 to 10, very alkaline solution, and that pH level is maintained by using ammonium hydroxide and ammonium chloride. So now onward, whenever you go into the lab and while doing the experiment, remember, why are you adding ammonium hydroxide and ammonium chloride? You are adding it to maintain a pH level of 8 to 10, because within that group only these members of 3A can be precipitated out. If suppose they are present, then they will come out. If on this pH level you are doing the experiment and you are not getting any precipitate, it means that group 3A is absent. And if you are getting a precipitate, it means that 3A group members are present. So these all are very enjoyable while doing the experiment. So hope soon you will be doing it in your college. So children, now it's time to move to see how this buffer action takes place. How these chemicals are. Now children, two types of the buffer solution which is included in our syllabus are this. Acidic buffer solution, they contain acetic acid and sodium acetate, means any weak acid and its salt of strong base, because the salt, the sodium salt is known as the salt of the weak acid and the strong base. Here we are writing a solution containing a weak acid. This is a weak acid, its salt with the strong base. Now see how this salt is formed. If suppose I am taking weak acid like acetic acid, treating it with a strong base, sodium hydroxide, H and OH will combine to form water, and this will come here to form CH3COONe. This is known as salt of weak acid and strong base. So this salt I am using here. Hence, it is known as a buffer solution of weak acid and its salt of strong base, because this was the strong base and this is the weak acid. And here we have given a equation. Derivation is not expected from you, it has been directly given to you. If suppose any solution I am preparing, then how to calculate pH of that solution? If suppose I am preparing a solution by adding some amount of acetic acid and some amount of sodium salt of acetic acid. After adding these two chemicals, I am finding that the solution is now a buffer solution. So how to calculate what is the pH value of the solution? Value will not change, I know, because it is a buffer solution. But what is that value? That we can calculate by using this formula. pH equals to pKa. Ka already we have seen in the, if suppose anyone is missing, he can see the previous videos, known as the dissociation constant. Now pKa, and if it is an acid, so pKa plus log to the base 10, so concentration of the salt, this is known as the salt, by concentration of the acid. Concentration of this acid and concentration of the salt. This formula will be very clear when you start doing the question, numericals. So at the end of this chapter, again we will be coming back to solve the numericals. Henderson, that is Hasselbalch equation, known as the Henderson-Hasselbalch equation. Name of the single person. Basic buffer solution. Of course, basic buffer solution is prepared by using a base and its salt with a strong acid, and that is obtained by using ammonium hydroxide and ammonium chloride. Now see, ammonium hydroxide is a weak base. If I am adding HCl, a strong acid, what will happen? This H and OH will combine to form water. Chlorine will come to this place. I am getting ammonium chloride. So ammonium chloride is known as salt of weak base and strong acid. And if suppose I have to prepare a basic solution, I will add some amount of the ammonium hydroxide, and after adding ammonium hydroxide, I will add ammonium chloride. And now this solution is known as the basic buffer solution. This is known as the basic buffer solution. Again the definition, basic buffer solution, a solution containing a weak base and its salt with a strong acid is the basic buffer solution. Now children, we have got acidic buffer solution as well as the basic buffer solution. In the acidic buffer solution, I am adding a weak acid like acetic acid and its sodium salt. Here I am adding weak base and its salt. This is the basic buffer solution. This is the acidic buffer solution. Now we will see how this buffer solution acts, how it works. And for that purpose, I am taking the example of acetic acid and the sodium salt of acetic acid. Acetic acid and its sodium salt. Now children, if suppose I have prepared a solution containing acetic acid and sodium salt of acetic acid. If suppose we are adding some amount of hydrogen ion, means if suppose some acids are added, of course for any normal solution, if you are adding the acid, pH value will change. How come that this acidic buffer solution will not allow its pH value to change? How it maintains the pH? If suppose the pH value is 5, it will remain 5. Even if you are adding acid, it will not change. How it works? Now see, moment H plus ion enters in the solution. Here in the solution we have got acetic acid and we have got sodium salt of acetic acid. Now sodium salt of acetic acid is a salt. This is a salt. And every salt is having this tendency to split 100%. It is a salt. In the water, it will split into ions. Though we are writing this formula, but inside the solution, what we are having is acetate ion and the sodium ion. Now what happens? This acetate ion will combine with the incoming hydrogen ion and it will form acetic acid, which is a weak acid. Now what happens? hydrogen ion which was coming from outside now has been locked. It is not free. Had it been free, it would have changed the pH value. pH is what? Number of hydrogen ions. Concentration of hydrogen ion. But now hydrogen ions are getting locked. They are not free. So this has become possible because of the acetate ion. As soon as H plus ion is coming, acetate ion will combine with that and it will form acetic acid. And acetic acid will keep that hydrogen ion with itself. Will not allow it to move and to change the pH. So this way, even if you are adding H plus ion, pH value will not change. Now, if I am taking simple water and I am adding hydrogen ion, what will happen? Hydrogen ion concentration will increase. And the water which was neutral, having pH value 7, will now change to say 6.5. Because there is nothing, no chemical present to lock this incoming H plus ion. And in this case, it is the acetate ion which is responsible in locking down hydrogen ion which is coming from outside. Now let's move towards the case when a hydroxide ion is added. Of course, hydroxide ion, if coming from outside, it is now acetic acid which will take the charge. Acetic acid is very weak acid. But hydroxide ion if comes, immediately hydrogen from here will go and react with hydroxide, forming water and acetate ion. From here bond will break. This bond will break. Hydrogen and hydroxide, they will combine to form water. Now see, hydroxide ion is not free. It is getting locked in the form of water. So water is a weak electrolyte. It will not split to that extent. Hence, pH value again will not be disturbed. So children, even if you are adding hydrogen ion or you are adding hydroxide ion, it is these chemical reactions which are responsible for the constant pH value. That pH value is not changing at all. After this, we can see even after adding water, why for pH value is not changing? Because here you are talking about the ratio of the concentrations. If you are adding the water, concentration of salt will change and equally the concentration of acid will change. So adding little bit of water will not affect to the pH value. So pH is not changing, either you are adding hydrogen ion or you are adding hydroxide ion. And third, even if you are adding water, pH is not going to change because in this pH calculation, you have taken the ratio of these two. So if addition of water will, if you are adding water, concentration of salt will change and acid will also change. Hence, both are in the ratio form. So, net effect is nothing. Hence, even if you are adding water, concentrations are getting neutralized and hence the pH value is not changing. Now, children, this is the acid. If you are adding some water, its concentration will change. This is the salt. You are adding water, concentration will change. But since both are present at the same solution, hence changes will be same. And the changes are same, so ratio remains the same. That is the explanation why even after adding water, the pH will not change. So children, this mechanism